In this problem, we want to find these two infinite limits and then any horizontal asymptotes if there are any. Okay, so we're finding the limit as x approaches positive or negative infinity, and I'm going to find them both at the same time. This rational function, so the secret is the same as with any rational function and x going out to infinity, is we're going to multiply by 1 over x to the highest power over itself. First, I'm just going to copy the problem though. So the highest power of x, it looks like it's at x to the 6th right there in the numerator. So I'm going to multiply by 1 over x to the 6th over 1 over x to the 6th and distribute that out over the numerator and the denominator. Okay, so 39x to the 6th times 1 over x to the 6th is going to be 39. Then plus 4x squared times 1 over x to the 6th is going to be 4 over x to the 4th. 15x to the 5th times 1 over x to the 6th is 15 over x. Minus 2 over x times 1 over x to the 6th is minus 2 over x to the 5th. So as x gets really, really large, either to positive or negative infinity, these three terms all approach 0. So this thing approaches 39 over 0. What's happening is this: if you plug in really, really large values for x, you're going to get numbers such as 39 divided by 0.000000, right? And the larger value you plug in for x, the larger or smaller your denominator is. But basically you have 39 divided by some really, really small number, which, I'm not sure if you can see my calculator, but okay, 39 divided by whatever small number is, 39 billion and so on. It just gets bigger and bigger. There we go. Okay, so that approaches, really it's hard to tell right now. We can't tell if it approaches positive infinity or negative infinity. There's no way to know. So to figure that out, you either need to make a table of values or look at the graph. Either way is going to be fine for a problem like this. So I'm going to graph it. Well, really remember we have two separate limits, so let's see. Okay, we're going to graph y equals 39x to the 6th plus 4x squared all divided by 15x to the 5th minus 2x. Okay, so there's the middle part. I'm going to have to zoom out. Okay, it looks like as it gets bigger and bigger, it's going to go out like this. Okay, it looks like that's going to go up to infinity. So I'm going to say the limit as x approaches infinity is infinity because of that right there. Let me zoom in a little bit again here. Yeah, right there. And then down here, that's going to keep going down forever. So the limit as x gets smaller and smaller out here going to negative infinity, those y's go down also to negative infinity. So limit as x goes to positive infinity. Oh, nice. They put some buttons down here for you. There you go, is infinity. And the limit as x approaches negative infinity is negative infinity. Okay. Okay, it's horizontal asymptote. When the power in the numerator is higher, the degree of the numerator, when that's higher than the degree of the denominator, there's not going to be any horizontal asymptotes. Excuse me. Those powers have to be either the same, excuse me, or the one on top has to be less in order to have a higher horizontal asymptote.